Hello student, today we are going to study about direction of electric current. This is brought to you by meritratio.com. Direction of electric current. In any electric circuit, direction of electric current is taken from the positive terminal of the cell up to the negative terminal of the cell. The direction of electric current is taken from the positive terminal of the cell up to the negative terminal of the cell, or the direction of electric current is taken opposite to the flow of electrons. Moving on the question, that is example 12.1 of NCERT, page number 200. A current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Current is given, that is 0.5 ampere, and time is given 10 minutes. Find the amount of electric charge. We are required to find the amount of electric charge that flows through the circuit. We are known from the formula of electric current, that is I is equal to Q upon T. So we can write Q is equal to IT. We have got the value of I, that is 0.5 ampere multiplied by 10 minutes. So we are required to change this 10 minutes into second. That will become 0.5 ampere into 10 into 60 second. Right now we can write this 10 into 60. This 10 will cancel to this 10, and it has come the value of 300 coulomb. Electric potential at a point and electric potential difference we have to study. First of all, we are required to understand if there is magnet. In this situation, it will have a field. Suppose there is paper pin is brought nearer to this. If it has got some magnetic field, in this situation, if it is kept at point A and brought nearer slowly at some particular distance, just say this is point B, in this situation, as it comes at point B, there is no need to bring this paper pin up to point further from point B, because at this point it will itself be attracted by the magnet. It will jump and just go to attract on the surface of magnet. So we can say that corresponding to this radius, a sphere will be created. A sphere will be created of this magnet that will be filled for this magnet. But any other point outside this radius will be called infinite, because if I am just putting this paper pin at point P, at point Q, at all these points, this paper pin will not experience that much of force, so that this paper pin may itself be attracted by the magnet. Similarly, there is field of any electric charged particle. Just suppose there is a very bigger charged particle like this. There is very bigger charged particle, and it has got some particular radius of sphere, and any other point. There are many points, that could be so many points, just like P, Q, R, S, T, so many other points. Any other point outside the radius of this sphere will be infinite points, and if any point is taken, and at that point, let us see, we are just placing a unit positive charge, which is also known as test charge, is placed at point P, and this point is brought from point P to point A, and this point is inside the electric field due to some bigger charge particle. As this charge particle, test charge particle, is brought at point A, in this situation, due to this bigger charge particle, it has also got positive sign, then this unit positive charge, 1 coulomb positive charge, will be repelled, and this test charge will come on the boundary of this sphere. For holding this 1 coulomb charge at point A, we are required to work. We are required to exert a force so that this test charge may remain stationary at point A. We are required to work. So this is defined work done in bringing unit positive charge from infinity, any other point outside the radius of this sphere, unit positive charge from infinity up to some point, and that point is present inside the field. Inside the field, as we have got this sphere inside the field due to some bigger charge particle, is called potential at point A. So we can write now electric potential at a point is defined as work done in bringing unit positive charge from infinity to a point. In our figure, this point is A. From infinity to a point A, and this point A lies within the field due to some bigger charge particle. We have got another question. We can add one more information, the SI unit of the SI unit of potential is V, volt, which is denoted by V as, and its SI unit is also V. It should be very clear, there should be no any confusion. So we can write VA is equal to W by Q, joule per coulomb. There is one question arises from this concept. Define potential at a point of 1 volt. Define potential at a point of 1 volt. As we have already known, potential at point A is equal to W upon Q. Work done in bringing unit positive charge, if that is 1 joule, from infinity to a point, is called potential at that point of 1 volt. Work done in bringing unit positive charge from infinity to a point. Work done, if work done be 1 joule, if work done be 1 joule in bringing unit positive charge from infinity to a point, and that point lies within the field due to some bigger charge particle. Charged particle is called potential at that point. Potential at that point of 1 volt. We have to again study about electric potential difference. For electric potential difference, if there is charge particle having very high value of charge, in this situation, if there are 2 points A and B, any positive unit positive charge is brought from point A to point B, whatever we are required to work done, because as this charge particle of 1 coulomb is brought nearer to bigger charge particle, in this situation we are required to exert greater amount of force, there will be greater value of work done. In this situation, if any unit positive charge particle is brought from one point to another point within the field due to some bigger charge particle, this is known as potential difference. Work done in bringing unit positive charge from one point to other point within the field due to some bigger charge particle. Some bigger charged particle. Is called potential difference. So we can write VAB is equal to W by Q. We have got another example 12.2 based on the concept electric potential difference. How much work is done in moving a charge of 2 coulomb. Charge is given how much? 2 coulomb across 2 points having a potential difference 12 volt. We know the formula of potential difference, that is VAB is equal to W by Q. We are given, so we can write W is equal to VAB into Q. So this further can be written. The potential is given, that is how much? 12 volt. 12 into 2. So this will become how much? 24 joule. We are normally required to use, or rather we are required to draw electric circuit diagram. For that there are different components and they have got different symbols. For electric cell, this is a longer vertical line and another is a small line. This is positive and this is negative taken. Group of cells or combination of cells, which is also known as battery, this can be further. So this can be added like this. Plug key or switch open. So this will be like this. Plug key, this is switch on. Whenever we switch on, in this situation in our circuit diagram we give a dot. Whenever switch is off, we do not give dot. Wire joint, for this we are required to just give a dot and a vertical line. At that place there is 2 wires are joined. Wires without wires crossing without joining. In this situation we can give a small loop. Electric bulb, we can just draw like this. This is our symbol for electric bulb. A resistance of value R, a resistor of value R, this can be, this is our symbol, zigzag. Variable resistance, we can just draw the diagram of variable resistance like, and we give a kink. So we can just move this kink either through the left or to the right to take the required amount of resistor. If there are 10 bulbs in series combination or in parallel combination, whatever be the situation, in this situation we can just move this kink. Through this we can get the required value of resistor. Ammeter, simply this is ammeter is always joined in series to the given circuit, and we have also got one thing, that is voltmeter. So this voltmeter has got the symbol like this. It is always joined parallel and across the resistor.